and the perpendicular geometry, this is the depth. The formula is the same, but we now no need to find the position, or sorry, we no need to calculate the position of the centroid along the ZZ axis, okay, or on the ZZ axis. Why? Is because by observation. So by observation, we know that ZZ axis is on that line because the area on the top is equal to the area at the bottom. So that is by observation, we know that ZZ line is the centroid. Okay. So now I'm going to call this section 1. Again, I'm going to divide the same. Section 2. Okay. So IZZ. Okay, so IZZ is equal to IZZ1 plus by IZZ2. Okay. So this will be equal to, so IZZ1, the width is 2. The depth is 8 cubed over 12 plus the width is 4. The depth is 2 cubed over 12. Okay, so it's so useful to identify which is your width and which is your depth initially. Okay, to formulate something like that. So 2 times y. Someone has a question. Sorry, I was carried away. I did not observe that. Okay, that was Tony at 8:12. Sorry. 2 times by 8 power 3 divided by 12 plus by 4 times 2 power 3 divided by 12. So it's equal to 88. Okay, it's equal to 88. Okay, right. So now we have most of the values that we need. Okay, so the next thing we're going to do is we're going to do the analysis part. Okay, we're going to do the analysis part. So I'm going to make this figure smaller. Okay, or this size. And we are going to formulate that table again. Okay, we're going to do a table again. So on over here, we are going to do, let me have a thicker pen. We are going to have, right, to take, to forgive me. So we are going to have moment about y, right? Right hand rule, compression, tensor. And then MZ. Okay, so this is our MZ. This will be compression. And this is tensor. Okay. So from here, we can now formulate. Let's look at stress X at point A. Okay, and it's important to know that vertical is our Y, horizontal is our Z. Okay, so if you look at point A, right, the Y distance from the centroid is equal to 1 inch, right? And on the Z from the centroid, right, from the Z on the centroid, so Z is the horizontal direction, right? So this is 4 inch, right? And then if we were to plug in the formula, so this is equal to my over Iyy multiplied by Z. We realize I don't put in the sign yet, right? So you know that moment about Y So we look at moment about y at point A is what? Compression. Then I put minus sign over here. Right? MZ, okay, MZ is also under what? MZ is also under compression. So 2 are minus. So that's why by looking at the moment vectors, I'm not worried about the what? I'm not worried about the formula at all. Can you all see how convenient this is, right? So this is equal to my. We calculated my is what? 3420. Okay, 3420 minus 3420 multiplied by z, which is 4, divided by IYY. So IYY is 64 minus MZ. MZ is 9397. Then multiply by 1 divided by IZZ is equal to 88. Right? So this will be equal to, let me post it higher up so I can just use this page. So this is equal to 3240 times 4 divided by 64 is equal to 201 is equal to 3420 times 4 divided by 64 is equal to 213 minus 213.75. Let me do it again. 3420 times 4 divided by 64. 213 and minus 9397. 9397 times 1 divided by 88. 106. 106.784. So this will be 213.75 plus 106.784 would be minus 320.534. Let me do again. 213.75 6.7. 320.534 ESI. Okay. 213.75 plus 106.784 534 323420 times 4 divided by 64. Sorry, I'm checking my calculation. Yep. Okay. So now we are going to look at stress X at point B. Right. So at point B, right, Y is equal to 1 inch. Right. Z is also equal to 4 inch. So it's the same, but watch what happened. Okay. So stress X at point B will be equal to my over Iyy multiplied by z, and then you have mz over izz multiplied by y. So at point B, right, moment about y, right, is also compression, so minus. However, point B, moment about z is positive, so the value change. So because I and z shares the same value, this will be equal to, and the moment and the second moment are the same. So this is equal to minus 213.75. Now we have a plus 106.784. Okay. So 213.75 minus 213.75 plus 106.784 is equal to minus 106.966. Yes, I. And finally, stress X at point D, right? Y, right? So Y at point D, the Y distance is what? 4 inches, all right? However, the Z, if you look at point D, right? At point D, right? The Z distance from the centroid is equal to 0 because D and the y-axis, which is the centroid, are at the same point. So Z is equal to 0. So this value changed slightly, but nothing ridiculous. So we know that Z is equal to 0. So this will be, so stress X at point D is equal to, so we know mz is equal to 0, right? And then the moment about y, sorry, the moment about z, okay, the moment about z is tension. So positive, okay, mz is equal to 9397, and then the y distance is 4, and divide by 88. Okay, so 9397 times 4 divided by 88. So it's equal to positive 427.136 psi. Okay, I'm gonna stop here. Okay, and I'll see you all of you on Thursday. Okay, I'll still be online if you have any question to ask.